Okay, so our goal for this section, in addition to just knowing what a quadratic is and knowing basic facts about the graph, our goal is to solve equations involving quadratics. In particular, we'd like to be able to solve equations where the quadratic is set equal to 0. This is a quadratic equation of one variable, because you see we don't have that second variable y floating around. It's just x's. And it's rare that we are going to want to devote an entire video or an entire set of notes to talking about something we are not going to learn to do. But I think this is a worthwhile discussion because most of you in high school will have come across the idea of factoring. And factoring, in theory, goes like this. Suppose you have an equation like this that you want to solve. You look at the left-hand side of this equality, and somehow or other, you recognize that this can be rewritten as the product of x minus 3 and x plus 2. And once you've done that, you apply the zero product property. And what the zero product property says is if you're multiplying two things together and the result is 0, then one of the things you're multiplying has to be 0. And then these little equations are easily solved, and you get values of x that satisfy this original equation. If you stick 3 in there, 9 minus 3 minus 6 is indeed 0. If you stick negative 2 in there, 4 minus negative 2 minus 6 is indeed 0. And I'm not going to teach factoring in this course. And the fundamental issue is that outside of a classroom, it doesn't work. Outside of a classroom, you're not going to be able to factor. As an example of what I mean by this, let's give an example from the real world, as it were. You launch an object with a velocity of 10 meters per second off a 7.5 meter platform. So don't ask me how I know this, because the answer is a combination of physics and calculus. But if x is the number of seconds since launch, and y is the height off the ground, then y equals negative 4.9 x squared plus 10x plus 7.5. And we ask, when will the object hit the ground? And we recognize that the object hits the ground when its height equals 0. So we set this height equation equal to 0. And now, if you've seen factoring in high school, for example, I invite you to try to factor this thing using grouping or whatever other methods you want. I'll wait, but you're not going to be able to. I mean, factoring just, once you have these decimals and stuff, factoring just doesn't work. And in real world situations, you're always going to have these decimals and the like. It's just the way things are. So because of that, because factoring can't really be applied outside of a classroom, I've elected not to discuss it beyond this discussion. And I maybe should add to that, I don't think math has to be useful in order to be elegant or beautiful. I've spent years of my life studying mathematics and taking classes that will never be applied to anything outside of maybe quantum physics. So I'm not saying factoring is inherently uninteresting. I'm certainly not criticizing if any of my colleagues do teach it. I'm just giving my personal philosophy of the essential studies, which is that an essential studies math class should seek connections to applications outside of mathematics, like, well, Newtonian physics you see here. And if such applications don't exist, it's maybe not an appropriate subject. Again, this is just my philosophy, but we are not going to learn factoring. We'll just forge ahead and introduce the quadratic formula.